In this video, I wanted to go over hypothesis testing for two means dependent. So in prior videos, we covered two proportions and also two means independent. This video, we're going to cover two means dependent. So first things first, let's cover or remind ourselves of what dependent samples and independent samples mean. So here's an example of two dependent samples and two independent samples. So for the dependent sample, you must have matched pairs. So in this example, we have matched pairs of heights of US presidents and heights of their main opponent. The first sample here would be the heights of president, and then the second sample is height of his main opponent. So for example, if the first president here was Barack Obama, then this height would correspond to John McCain, right? John McCain's height, if we were considering the first time Obama ran for president. All right, and that's what creates a matched pairs. There's a inherent relationship between the first pair of data. And so, for example, this second president, this is his height. This was the height of his main opponent. So let's look at the second sample or second example of heights. So this is an independent samples, or these are independent samples. We have heights of males and females that are listed together, but there is no relationship between the males and the females. So the first set is the height of males, second set is height of females, but there is no relationship between, say, this first male and this first female. So this pair, the first pair, there is no relationship between that male and that female. All right, so dependent, match pairs, independent, no match pairs. In this section, we're going to cover two samples where the samples are dependent. So a few new notations we're going to look at. The first notation is D, individual differences between matched pairs. Mu sub D, population mean of the differences, D's. D bar is the sample mean of the differences. S sub D is the sample standard deviation of the differences, and then N is the number of pairs in the sample. So let's look at this example, and let's figure out what each of these mean for this example. All right, so again, this is the matched pairs of heights for the US president. So D would mean the individual differences between each matched pair. So D is a set. So the first D would be the difference between 189 and 170, so that would be 19. The second D, difference between these two values, that's negative 12. Third one, difference between these two, positive 8. Difference between these two, this pair, is 0. Difference between this pair would be 1. All right, so this is my set of Ds. These are the individual differences between matched pairs. Mu sub D is the population mean of the differences. So in order to get mu sub D, we would need the match or the heights of all the presidents and all of their main opponents, and then calculate the differences for each of those pairs, and then calculate the mean of all of those Ds. Here we clearly do not have all of those values, so mu sub D is unknown. And that's usually the case. We hardly ever know mu sub D because we don't have, in order to know mu sub D, we would have data for the whole population, right? Okay, and D bar is the average of the differences for the sample. So in this case, D bar is the average or the mean of these values. And we can calculate that by hand if we like, right? We add them all up and then just divide by however many values there are. So in this case, there's 5 values. Add up all these, divide by 5, and I had worked this out already. You would get 3.2. So D bar is 3.2. S sub D would be the sample standard deviation, so the sample standard deviation for this set. So instead of working it out by hand or using the formula, I'm going to show you guys how to do that using the TI-84 calculator. So in order to do that, we're going to create two lists. So the first list is for the height of the president. The second list would be the height of the main opponent. So I'm going to go to Stat, Edit, and I already have the heights inputted. So this is the heights of the presidents, which are these values, and then this is the heights of the main opponent, which are these values. And to get, the next thing is we want to create the difference list. So we want to create this list. So an easy way to do that is we're going to go to the right to a new list. So in this case, L3. We're going to press up so that L3 is highlighted. Press Enter. And notice how there's a blinking cursor here. We can define what L3 is equal to. So in this case, L3 is a difference list. So we're going to subtract the values in L1 with L2. And here's how you would do that. You would just do L1 minus L2. So second 1 minus second 2, enter. And notice how I created my D's lists. All right, these were the D's that I did in my head. And you can do it this way as well. So again, 189 subtract 170 is 19. 173 subtract 185, negative 12, and so on. All right, so now that we have the D's list, again, we want to get S sub D, which is a sample standard deviation. So in order to do that, we're going to run a function called oneVarstats. So what you want to do is go to a stat, go to calc, oneVarstats, press enter. We want to put list 3 here, right? That's where we put the list of the D's. So it's already list 3. It's already has it there. Frequency list, we don't need it this time. We don't have one. So we're going to go to calculate. There it is. So instead of X's, these are really the D's. So this would be D bar 3.2, and that's what we have right here, right? And then S sub D would be S sub X, 11.4. So let's write that down. So the last value we need is N. So N is the number of pairs in the sample. So in this case, there's 5 pairs. So if I go back here, there's 5 pairs, right? There's 1, 2, 3, 4, 5 pairs, 5 matched pairs. All right, so hopefully you found that helpful. In another video, I'm going to show you guys how to perform a hypothesis test for 2 dependent means. If you have any questions, again, let me know.